Problem number 10 discusses how the number of customers in a dye shop increases with the money they spend on advertising. They give us two inputs and outputs being 0 and 100, and then 100 and 200. Those are going to be 2 points we use later. And then they say that the number of customers per day increases and approaches but never exceeds 400 customers per day. And part A asks us to find a linear to linear rational function, y equals f of x, that calculates the number of y of customers per day if x dollars is spent on advertising. So the first thing you should do is collect your information that's given. So we have 0, 100, 100, and 200, which we already mentioned. And then we have our linear to linear function, which is ax plus b over x plus c. I've heard other ways of doing this, like ax plus b over cx plus d, but at the end, what is going to get used the same thing. I think that, using this formula is easier. So for what we want to do is create a series of equations using f of x. So we have f of x is equal to 0a plus b over 0 plus c equals 100. That's basically our 0, 100 that we plugged into this equation. And then we do the same thing for f of 100, and you get 100a plus b over 100 plus c equals 200. And then you need to solve for the variables. So we know that a is equal to 400 because in this equation, what a defines is the horizontal asymptote. And it's given to us when they say the number of customers per day approaches but never exceeds 400. So a equals 400. So then we need to, we just use these equations to solve for the other variables. So we know that b over c equals 100 because these zeros cancel out. It looks like that. And then b equals 100c. Then we plug b equals 100c into our other equation. And then you get 100 times 400 plus 100c over 100 plus c, and get 200 for that, for c, excuse me. So now we have a and c. We plug that back into one of the formulas. Over here we have b over c equals 100. C is 200, we just figured that out, so b over 200 equals 100, and so b equals 20,000. So now we have a, b, and c. We can plug that into our linear to linear function. So ax plus b over x plus c is 400x plus 20,000 all over x plus 200. Part B asks how much the shop must spend on advertising to have 300 customers per day. So we just use our function that we just created and plug in 300 for y and solve for x, and you get x is equal to $400. Part C asks us to sketch a graph. So what it looks like is you have your 2 points that we talked about, and then I just created a table. And we know that the horizontal asymptote is 400. It sets the domain at 5,000, so basically it just has this coming out here, but never touching 400. F of x asks us to find the inverse of that function. So basically, you just flop the x and the y, and then solve for y again. So we did that. You end up with 200x minus 20,000 all over 400 minus x is equal to y, and then ask for the domain in the range. So the domain in the range of f prime of x is the same as f of x. So we know that the domain from up here, f of x, is 0 to 5,000, because it asks us to plot it from 0 to 5,000. And then we know that the range is going to be 400 because our horizontal asymptote is 400. Though it's actually not quite 400 because you plug 5,000 into this function, you get like 388.4. But if you want the true domain range, then the domain is pretty much in 0 to infinity, and the range is less than 400. But since we're given the restriction 0 to 5,000, we'll just stick to that. So we just flip flop them. So the range of f prime of x is going to be between 0 and 5,000, and the domain is going to be between 100. Oh, because we start at 100. Or that's going to be 0. Excuse me. That's 0. And it's going to be, and then x is going to be less than 388.4. And so what the inverse equation is telling us is how spending on advertising increases as customers increase.